Hello, this is Meep, and welcome to Meep's Math Matters. Today I'm going to be looking at the sum of consecutive even and odd numbers. From the last video, I showed that 1 plus 2 plus 3, etc., adding up all the whole numbers, 1 up to n, is n times n plus 1 over 2. Okay, before I go on to the even and odd numbers, how do we know that n times n plus 1 over 2 is a whole number itself? I'm adding up a bunch of whole numbers. We know that means it's going to be another whole number. You don't add up 1 and 5 and get 17.3. Whole numbers plus whole numbers are whole numbers. So how do I know this is a whole number? Well, let's consider the concept of even and odd numbers. So an even number, you can represent it as 2 times some whole number. So as an example, 12 is 2 times 6. So it's even. Okay, so 2 times some whole number is an even number. And an odd number, there's a couple ways you can represent. Now, odd number is a whole number that's not even, so you can make it look like 2 times some whole number minus 1, or 2 times some whole number plus 1. So as an example, 5, that equals 2 times 3 minus 1. It also equals 2 times 2 plus 1. You use whichever is most convenient to you. Well, let's look at, if you look at a number line, okay, you have numbers 1, 2, 3, 4, etc. You notice that the even numbers, which I'm underlining in orange, alternate with the odd numbers, which I'm underlining in blue. Okay, so go back to this n times n plus 1 over 2. If n is even, okay, then no problem, you can divide by 2. That's all. N is either even or odd, so if it's even it works. If n is odd, then n plus 1 has to be even. Okay, think about that, and then you can divide by 2. In any case, it works. But now what I'm going to do is take all the even numbers and add them up. Okay, consecutive even numbers, get a formula for that, and do the same with odd numbers. So let's get to it. Adding up the consecutive even numbers. So I'm going to make it look like 2 plus 4 plus 6 plus 8, etc. And I'm doing it up to an even number 2k. So I'm writing it like this, so it's obviously an even number, and we're going to get our formula in terms of k. And we have to be careful about that. Okay, we'll see why in a moment. Now, I can do this with arithmetic. I'm going to factor out a 2. Okay, that means each term is going to get divided by 2. Because they're even, I can do this. So 2 is 2 times 1. 4 is 2 times 2. 6 is 2 times 3. Okay, up to the last 2 terms, which will give me k minus 1 and k. Oh, look there, we have the sum of the consecutive numbers from 1 to k. We have a formula for that already. Okay, so we have that 2 out front, don't forget it, times my formula for what's inside, so that's going to be k times k plus 1 divided by 2. And you notice these 2 times and divided by 2, they cancel each other out, so your final formula is k times k plus 1. Now again, remember, okay, let me give you a concrete example here. So 2 plus 4 plus 6, etc., plus 98 plus 100. Okay, what is k here? K is 50. Okay, the last item is 2 times k, so we're going to divide 100 by 2. That gives me 50. So my answer here is going to be 50 times 51, which is 2,550. Now there is a way to do this with the dots that I had showed before when I was doing the summation. And what you do is you take each even number. Okay, so like 2 can be divided up into 2 dots, 1 each. So here's my 1 for 2, and here's my other 1 for 2. For 4, it's 2 plus 2. For 6, I've got 3 over here and 3 here. Okay, and we're going to end up with our triangles as before. Okay, so let me do the last one here. I have K dots, K purple dots, and K purple dots over here. So you notice that there are K columns, and as before, there are K plus 1 rows. The difference here is, versus the time when I was summing the consecutive numbers, is that this is the full sum. I haven't duplicated anything. What I did is for each number, I split it in half and put half of its dots on one side and the other half of its dot on the other side. So again, we get K times K plus 1. Now let's look at odd numbers. So adding up the consecutive odd numbers, 1 plus 3 plus 5 plus 7 plus 9, etc., up to some highest odd number that you're going to pick. I'm going to say 2n minus 1. Remember, you can do it as an even number plus 1 or an even number minus 1. It doesn't make any difference. Okay, now I'm going to draw a picture. I'm going to do it in a different way from when we had last time. I've got my 1. Okay, 1 dot, simple enough. Now 3. I'm going to do it like this. Make a little square. I wonder if I can keep doing that. 5. 1, 2, 3, 4, 5. Interesting. Let's go to 7. 1, 2, 3, 4, 5, 6, 7. Notice I have a square. Okay? What is the side of this square? Okay, at 1, the side of the square is 1. For 3, the side of the square is 2. For 5, the side of the square is 3. Okay, so if you're looking at this as these purple dots are the 2n minus 1, the side of the square is n. This sum is n squared. Try this, okay? You challenge somebody. What's 1 plus 3 plus 5 up to 99? Okay, what you do is you add 1 to the 99. That gets you to 100. Take half that. That will give you your n. This is 50 squared. That's 2,500, 2,500. Now what's great is you can combine this with this the previous 2 plus 4 plus 6 all the way up to 100. Remember? We saw that was 2,550. If we add these two together, what do we get? We get 5,050, which is the sum 1 plus 2 plus up to 100. It works. But still, try this out for yourselves. Do it in a spreadsheet or do small amounts of numbers. Make sure this formula works. This is a great party trick. Challenge someone, what's 1 plus 3 plus 5 all the way up to 99, and say you have a contest. You can get there first. And of course, you can prove it once you get your answer. I can be contacted at marypat.campbell@gmail.com, and remember to spread the math love.